Hello everyone, my name is Spencer Allingham and I'm the Technical Director at Conducive. I was asked recently, actually by a couple of customers, if the Velocity and Diskkeeper software is still relevant if they start using all flash arrays or SSD, really today's faster storage. Is there still a place for Velocity and Diskkeeper? Now, the short answer to that, of course, is yes. And I would say that I work for the company. But today, in this video, I would actually like to prove it one way or another. And then you can decide for yourself whether the software is relevant. For those of you that don't know, Velocity and Diskkeeper are both designed to significantly reduce the amount of storage I/O traffic that the underlying storage in your compute environments have to deal with. Now, why would you do that? Well, it has a very beneficial effect, both on performance and the number of workloads that you can host above that same shared storage. So, for example, let's say you've got a virtualized environment. So you're running either Hyper-V or VMware or some other type of hypervisor. And at the back end, you might have a storage area network or SAN, or you might have direct attached disks in the physical host. That storage is pretty much always going to be the slowest part of the estate. If you compare the speed at which things can happen down at the storage layer to the speed at which things happen at a processor layer or in server-side DRAM, those latter two are always going to be the faster for operations and the transactions that you're doing. So the more you can reduce the amount of work that slower back-end storage has to deal with, the better, the faster, the more performant all of those workloads and applications that you're running along the top are going to be. So the other benefit, other than just performance, is that by reducing the amount of storage I/O traffic, I/O is input, output, it's the transfer of data between the Windows operating system and the back-end storage, in this case anyway. The more you can reduce those I/O operations, the more bandwidth you have in that network pipe between server and storage. And the more room you have in that pipe, the more machines you can host over that storage, the more workloads you can run, the more instances of SQL Server or SharePoint or file and print servers. You can basically host more machines over that same shared storage than you otherwise would be able to do. And that can only be a good thing for the return on the investment that you made in that storage, especially if it's expensive storage. So, forgive me, I'm going a bit off topic. So I was asked recently by a couple of customers, is the Velocity I/O reduction software still worthwhile using in environments that use very fast storage such as flash or SSD? And as luck would have it, I have treated myself to one of these. So this is a NAND flash SSD stick, basically. It's the Samsung SM961 Polaris 1 terabyte for you other geeks and nerds out there. What I can tell you is it's very fast. I mean, huge amounts of IOs per second, huge amounts of throughput. For my workstation machine, I've never used a machine that's as fast as this that I've ever owned. So very pleased with the upgrade. But the question is our software still relevant? So what I'm going to do is a lab test where I can spin up two machines, and I have them ready here. I'll just minimize that. So I've got a machine here on this side, which is a clone of this virtual machine here. So they're both running Windows Server 2016. They both will have a copy of Velocity installed. I'm going to do that in just a second. And I'm going to run up a copy of IOmeter on both and run what is roughly a sort of, if there is such a thing as an average SQL type workload. That's what I'm going to try and do. You'll see the specification. I'll be quite transparent about that. And if you guys agree or disagree with the I/O workload configuration, well, please feel free to put your comments below. And if I need to redo this test, I'll be happy to do it because, frankly, I love playing around with this stuff. It's good fun. So, without further ado, what I'm going to do is we'll flip over to that screen so that you can see it properly. And we'll get everything set up. We'll run the test. And we'll see, will the copy of IOmeter on the machine with Velocity enabled be able to get more work done in the same amount of time? Will it be able to process more IOs per second, more throughput in megabytes per second? Basically, will it allow you to get more work done in the same amount of time, even though I'm already running very fast NVMe storage? Let's see. I haven't pre-run this test, so hopefully the results will be good. I've done that on purpose so that I can hopefully be pleasantly surprised, and hopefully you will be as well. And look, if it does show that we can get more work done in the same amount of time, just have a think what we can do for you guys as well in your real world environments. So anyway, enough talking from me. Let's flip over to here, and we'll start setting up the test and letting it run.
Okay, so here we are on my main desktop. Forgive this little window up here on the top right. That's the screen recording studio I'm using. That's got nothing to do with this test. But what does, as I mentioned before, are these two virtual machines, both running Windows Server 2016. So what I'm first going to do is install a copy of the V-locity software onto both of them. Then on this one on the left, I'm going to make sure it's disabled so it can't actually do anything, and then we'll generate a workload with Iometer and get the testing done. So let's install a copy of V-locity first of all. I've got a copy installed here. Sorry, a copy ready to install here. So let's run that on this machine. Now you'll notice during the install, or more importantly just after the install, what I don't have to do. And that is I don't have to reboot the machine. I can install this software onto any live machine without disrupting its running workloads by having to reboot in any way. As you can see, it's super easy to install, literally takes a minute or so. And then once it's installed, a few minutes after that, it will start providing benefit to the environment and making things perform better and easing the load a bit on that back-end storage. So that should complete. Okay, there we go. That's completed now. So V-locity is installed on there. So what I'm going to do is use this as my benchmark machine. So what I'm going to do is open up V-locity and effectively disable it so that it can't provide benefit on this machine. So we'll go into the configuration here and basically turn all of the optimization features off and say apply. Okay, so V-locity is installed on there. Now to make sure these machines are exactly the same, I'm going to install it onto the other machine as well. Here we go. Let's run the installer. And again, won't have to reboot, which is good. That was a great new feature that they introduced into V-locity 7 and Diskkeeper 18. Previously, having to reboot was an absolute pain in the backside. Thankfully, now a thing of the past. Okay, so now V-locity is installed on both machines. Only this one here on the right is going to have the benefit from the software, those features turned on. So now let's fire up a copy of Iometer on both. In fact, let's bring up V-locity on here as well so that we keep everything exactly the same. Okay, so the reason why we've got this spinning wheel is because the V-locity software is still effectively initializing. After a few minutes, you'll start to see dashboard report data being populated on here. And I'll show you that in more detail when we've actually got some data to take a look at. So for now, I'm going to run a copy of Iometer on both machines, and this is what I'm going to use to actually generate the workload. And as I mentioned before, I'm going to roughly try and create a workload that you might typically see on something like a SQL server. Now, feel free to comment on this, as I mentioned before, but there is no such thing as a typical SQL server load. So you can agree or disagree, and feel free to let me know. But I'll create a worker. In fact, I'll create two workers on drive C, and we'll do exactly the same over here. The workers are the things that actually create and control the workload that I'm going to specify. So let's specify them. So I'm going to create a couple of new access specifications. So we'll call this one SQL1, and we'll have it do storage IO requests that are 16 kilobytes in size. We'll leave it at 100% random, so that it should be even more difficult for the Velocity software to determine what to cache, or give it a bit of a test there. And we'll leave this as it is. So it's going to be generating roughly 33% write IO traffic and 67% read traffic. So that'll be our SQL1. There we are down there, and I'm going to do another one which I'm going to call SQL2. Not very imaginative, I know, but there you go. And this one I'm going to do slightly larger packet sizes of 64 kilobytes. Again, 100% random, and we'll leave the percent of read and write the same. Okay, so now we've got SQL1 and SQL2. So I'm going to do the same on the machine that has Velocity installed. So exactly the same setup. So SQL1 is going to have 16 kilobytes per packet, 100% random, 33% writes, 67% reads. And then we'll set up SQL2 as well. Good, and we'll have that at 64 kilobytes. Okay, so now on both machines we have our access specifications set up, and now we need to assign them to the workers. So we'll assign SQL1 to worker 1, and to worker 2, that's it, you've guessed it, we'll assign SQL2. And we'll do the same over here as well. So now both machines are set up in exactly the same way. So let's set up the results display. We'll say update every couple of seconds. We'll do that on both machines as well. Okay, good. And we will look at all of these metrics, but for now let's concentrate on the number of IOs per second that Iometer is able to create and have processed on both machines. So what I'm going to do, just to make it a little bit more visual, is set up a speedo dial here, and we'll set that to, let's try 30,000. Okay, so the maximum on that dial is 30,000 IOs per second, and we'll do exactly the same over here. So now what remains is to start Iometer generating those workloads on both machines. Remember, this one on the left is the one that has Velocity installed, but it's disabled. So Iometer basically is going to be running just as if Velocity wasn't installed. It's going to be exactly the same. And the one on the right over here, this one has Velocity installed and it's all enabled. So if I'm right, and this test goes the way I'm hoping it will, this one should be able to process, after a few minutes, a higher amount of I/O traffic, more IOs per second than this one on the left that's just running vanilla or generic. So which one shall I start first? It probably doesn't really make a great deal of difference, but we'll start the non-Velocity machine first. There we go, and after a moment it'll start generating IOs. Okay, there we go. So it started off by generating about 13,000 IOs per second. Now let's start this one over here, and initially they're going to be roughly at the same sort of level, which they are, thankfully. Don't have egg on my face yet. Okay, so now what we need to do is just wait for a few minutes, and Velocity on this machine on the right will start learning about the workload that's being run. And that's one of the clever things about the software. It uses a telemetry technique to learn over time what type of applications are installed, what type of files are being accessed, what type of storage I/O streams are being generated, and at what times of the day, the week, the month, the quarter. So it can really use that intelligence to become very clever about, for example, what data needs to be put into the RAM cache that's in the software, and more importantly, when. And also how best to size those I/O packets to give whatever the main application is the very best performance. And the great thing about it being an automatic telemetry technique is that if the way you use those machines change over time, the Velocity software will automatically adapt to those changes without you having to go and reconfigure anything in Velocity or really play with it at all. It's all very much a set it and forget it type product, and it will just always try and do the very best it can. So I'm looking now back at the IOs per second. It's still roughly the same on both machines, so Velocity is still going through its learning curve. But very soon we should start to see that creep up a bit on the right, and it looks like it might be starting to a little bit. Oh, look at that! So 13,000 to 21,000. That's pretty good. So clearly more IOs per second are being done by the machine with Velocity installed. Now that's predominantly going to be because of that RAM caching. What it's done is figured out those read IOs that can be cached. It's got that data into server-side RAM, and it's satisfying those read requests from there. Now, I mentioned at the beginning that I'm using a NAND flash drive here. It's super fast, well, as fast as it is, I mean, natively with this test about 12,000 IOs per second, which is really not to be sniffed at. That's pretty fast. But with Velocity installed, using that RAM is clearly faster, even still, than that new flash drive that I've got in there. And the results are proving it. What is that? That's roughly 8,000 more IOs can be processed every second. Now, that's great for really busy machines. But think what sort of impact that type of software technology could have if you have a virtual environment or a mixed physical server and VM environment where they're sharing that same back-end storage, where they're sharing a SAN, for example. You've got loads of workloads generating lots of storage I/O traffic, and it's all being funneled down through that host hypervisor and then on down to the storage at the back end. Imagine how much more work those machines can get done when we're reducing that storage I/O traffic that actually has to go out to that slower storage and start really utilizing the power of that server-side RAM to really boost the performance of the applications. So let's close off those DAS for a moment and have a quick look at some of those other metrics in Iometer. So again, here at the top, this is the total number of IOs per second. So it's running at about 12,500 on the machine without Velocity, and over 20,000 on average. So a significant increase. In terms of the amount of data that's being processed, how much is being throughput, that's the next one here in total megabytes per second. So natively, it's, let's say, is that about 490 megabytes per second, roughly. On the one with Velocity installed, that's over 700 megabytes per second. So clearly, it's processing a greater amount of work. The next one is the average I/O response time in milliseconds. So that's how long is it taking to satisfy an I/O request on average. So natively, I said this storage was very fast. It's 0.15 milliseconds. The one with Velocity, though, is 0.09. So it's taking less time to satisfy I/O requests on the machine with Velocity installed. Now this is quite interesting as well. The amount of CPU utilization, it seems to be roughly the same. It's fluctuating a bit on both. So basically we're getting more work done clearly on this machine on the right with Velocity installed, but we're really not using any more CPU or processor time. I would say this is a pretty successful test. So in answer to the question, is Velocity still relevant, or Diskkeeper for that matter, which is Velocity's sister product for physical Windows servers, I would say yes. If you care about performance and you really want to get the most out of your back-end storage, even if it is SSD, NAND, flash, An old flash array SAN, that's an expensive piece of kit. If you want to get the very most out of it, this is clearly a very easy way to do it. You saw how easy the software was to install. It's not terribly expensive, unfortunately, which is why I'm still having to work doing videos like this. No, all joking aside, it's not hugely expensive. It's a hell of a lot less than what you would need to spend in hardware to get the same type of performance gains. But if you care about getting the most out of your storage, easy enough to give it a try. You can get a free, no obligation 30-day trial. So that will run fully featured for the whole 30 days. And all you need to do to get that is to go to conducive.com/try. In fact, I'll show you. Let me fire up my browser again. So conducive.com/try, and you'll see there's a little form you fill out, and then within minutes you can be up and running with that software yourself. Let's make sure that's big enough for everyone to see. There we go. There we go. Simple registration form. You then get the software, 30 days, run it, and that's the important thing, because running lab tests is great to prove that the software works as advertised, and it's great to prove that it can still make a difference with very fast, high IOPS storage. But what's more important is, what can it actually do for you with the real world workloads that you run, with your applications, in your hardware environment? What difference can it make for you? Run it. And see. It's going to cost you nothing other than the couple of minutes it takes to fill out that form, download and install the software. You're not going to disrupt anything. You saw there were no reboots required. Those live running workloads can stay live, up and running. Run it for a couple of weeks, and then pull up the dashboard data here and see how much of that I/O traffic has been eliminated from having to go out to the storage. See what it can do for you. Now, just in case, I'm going to bring up these dials again. So clearly, velocity is having a beneficial effect on here. But how can we be certain? How can we be doubly certain that it's definitely the velocity software that's causing this increase in workload to be processed? Well, I guess the easiest way is to suddenly turn velocity off. So the quickest way of doing that is just to stop the velocity service. So let's do that. Net stop velocity. I'll make that a window a bit smaller, so we should be able to see a pretty immediate effect on this dial, and it should drop down to about 12,000 or 13,000, similar to the one on the left where velocity is not optimizing anything. So I am going to hit the enter key right now, and let's see if that needle drops. Okay, the velocity service has stopped, and yes, it's immediately dropped back down. So now both machines are running just as they would as if velocity wasn't present. Now, just for a giggle, let's start it back up again. Let's start velocity. Now, again, the service is starting up. It will take a couple of minutes to re-establish the cache and start providing benefit, but very quickly we should start to see this needle move, just as we did before when we first started it up. So let's give that a moment to kick in and get initialized, and we'll see if that needle starts moving again. Come on, velocity, don't let me down. No, it does take a couple of minutes after starting it to start providing the benefit again. Oh, there it goes. Okay, so literally within minutes of getting that software installed, it should be providing a beneficial effect. Well, I would say that's a pretty successful test. It certainly answers the question. If you have very fast flash storage, can the environment do more? Clearly, yes, it can. So the only question that I have is, why don't you try it? Download it and see. And I'd love to hear your comments on this video down below. Let me know what you think. If you like this type of test and you're as geeky as I am, let me know. Maybe suggest other tests that I can do. I'll be happy to do that. And yeah, let's really put it through its paces. And don't forget, if you want to try the software, conducive.com/try. So thank you very much for taking the time to look at this. I hope it's been interesting. And yeah, feel free to reach out to me if I can do any other videos like this. All right, everyone, take care. Cheers.